last video I have described the problems related to the equation. First part of that I have completed the linear equation, then after the quadratic equation, and the last class was the end of the lessons related to the, because I have described several problems that I feel is sufficient for now. If in future if anything comes to be discussed, then definitely I'll bring more videos on that. Now I'll move to not actually the mathematics, but it is a kind of related subjects which needs mathematics in it. It is a subject of physics. It's called kinematics. So I will describe onwards the theories and concepts related to kinematics, and the subjects that I've taught till now, that will also help us to understand this subject kinematics. Okay, this is a you can say a chapter or a part of a physics. Is a part, definitely a part of physics, where I learn the motion of any object or particle and their characteristic. So first understand what is kinematics. If I break it into two parts, that is kine and matics. Kine means motion and matics related to mathematics. So if I combine these two words together, the meaning which will come is that the mathematics of a motion of any object is taught or understood in the subject under kinematics. So any object or any particle in whole universe which are in motion, there are some relation with their motion and the timeline and the time. You can say that all relations and all calculation regarding their motion, which comes under as a mathematics equation, and we can relate those equations to each other, or the you can say or we can say study those characteristic of motions in kinematics. So kinematics as a whole is the related to the motion of an object and their calculation. Here I am not talking about the cause of the motion. Cause of the motion, that is not included. So that means I am not considering the force required to give any object which will be in motion or become in a state of rest. The cause is only be the force. By applying this towards the motion or against the motion, I can change, but that cause I will not will not study in under the belt of kinematics. So kinematics is only the motion of an object and their calculation. There I will not talk about any force or the any reason for which the motion is causing. Okay, so this is the part to be understood first. Then the part that has to be understood, there are some, because in physics no subject is isolated. If we study any subject, that is the combination of several other subjects to make understand about the subject and to get the relations and their respective calculations to fetch some value out of it. I need several things to be studied together. So as of now, to understand kinematics or to study the kinematics, I need few subjects. The subjects is equation. I think equation are well covered. So the part of the equation which will be useful that I have taught, that is linear equation and quadratic equation. These two subjects I have already taught you, and related sums also I have covered. So this is the one part. Second part is reference frame. So bit of it I have covered in while I am discussing the linear equation, because the frame is, I taught you the x and y coordinate system, that we call it the reference frame, because these are all relative, because motions is relative to each other, that I have already told during discussing the linear equation problem. I need an imaginary reference system which is consisted of two axes if it is in a plane. It could be of three axes if it is in a space. These are called the reference frame or the coordinate system. Third thing that has to be discussed is the quantity as a whole and their bifurcation, scalar and vector. Okay, so with this all known, that could build a base to discuss about the kinematics and their relations. So let me come to the first part, that I am not going to teach you further, because whatever I have taught, it is enough to understand kinematics. A reference frame is, I have told one thing, that in a plane there are two coordinate systems, in a space there are three coordinate systems, x, y and z or z, whatever you say. Only thing that I have to tell you about reference system, that it could be in motion or in rest. So this has to be understood to understand the kinematics. Why I am saying in motion and rest? Because you see that reference frame that I have told, these are all imaginary in nature. There is no real existence in universe. You cannot say that this particular place or point has to be the reference point for all things I have to consider, because this reference frame is an imaginary referring point or referring axis, you can say, or reference plane, you can say. All things can be a point, can be a axis, or can be a plane. Whatever you consider, this is not fixed at all. This is imaginary, and for your calculation, for your you can say for your comfort, you can take anywhere, anything as a reference frame. So if that is the case, if reference frame is not fixed at all, so for my consideration of studying a motion of a body, I can choose any such thing which is helpful to consider the motion and to establish the relation of the motion. So from that I can say there can be a motion in rest. So take some example where this can be further cleared very much. So I am rubbing this out. This part I am rubbing. So I am discussing on the reference frame. Let's say some person is standing there on a road, and he or she is viewing one vehicle is moving on a path, he is standing, he is stand still, he is in rest or she is in rest. He is seeing the vehicle to move with certain you can say that car is moving, that means it has some motion. It's with motion it is moving. So if it is stand still with reference to him, if he seeing that car is moving faster or slower, that assumption he can make, because he is a reference from for our study. If he is the reference frame, what he can see whether a car is moving faster, or it will be more comparative if I take another car on the same track moving parallel to it, and this car after certain time crosses this car far away, and whereas this is still going behind, so he can make an assumption that this car is moving faster than this car. So in that case, if two cars I'm considering with respect to this person stand still, it is moving faster or slower, he is my reference frame, and this reference frame is in rest. So understood? He could be my reference frame if I want to consider any motion calculation or relation between this car. Now I can, this is car 1, car 2. I can easily say car 1 moving faster than car 2, as he has crosses this car behind, and this is my reference frame, can see it properly. So I can put this relation viable or true with respect to this frame. Now suppose somebody is driving here, he is the driver and there is a driver too. Now if this driver sees this car, what he can see, he is moving with some motion, he is also, but this car can see this is slowly passing it by his car, and he also can see that car is faster than me, but what he can see, his assumption would be a different way. Now this is C1, C2. If I say the speed of car 1, this is speed of car 2. So for him, both the car having speed, they may be different. But if he sees, he can considerably say that this car also moving fast, this car also moving faster, and this car is faster than this and can cross over. So for him, these two speed are high. But if you consider this reference frame as a driver, and if he sees this car, he can tell, yes, this is having a higher speed and slowly crossing me. Slowly, he would say slowly crossing me. He can make a sense that this car having high speed or motion than him, but that is not too much high. He will not assume that. And moreover, if the driver here is our reference frame, what he sees this car as, he is slower and he is going back, is going back to my car. He is not able to move along with me, he is going back, rather not going forward even. So if this are the reference frame respectively, then his point of view and his point of view is not as good as his point of view. So my reference frame could be in motion, in standstill. So this reference frame in motion, because this could be my reference frame, because I could be the observer to observe other car's velocity with respect to his velocity, whether it is higher or lesser. If it is lesser, let's say he is the observer, then if it is lesser, then he will see that car is moving backwards rather to forward, because he is crossing himself the slowest car, so that car with reference to him will move out. So what my impact of saying is that if the reference frame is moving along with the object which is moving, that means the observer is sitting on the object which is moving, so there is no difference in speed between them. The object is moving with some speed, and the observer sitting on it is also moving with the same speed. So in between there is no difference of speed, so he cannot see this vehicle is moving. Rather he can assume that I am stand still, and whatever moving uh, moving forward is moving faster, or whatever moving backward, uh, whatever the vehicle is slower, he will assume that vehicle is moving backwards. So the faster vehicle, he will assume that it is going forward. So for him, the assumption is that the vehicle which is faster is moving forward, and vehicle which is slower will be going backward. So he will say like that. So he will not say similar to this. This guy can say which one is faster, is moving ahead of the slower vehicle. His statement will be like that. Whereas the observer, if he is sitting on the reference frame and the reference frame itself is moving, he will say that car is moving forward or the car is moving backward. So there could be a different statement if the reference frame changes. So my point is that a reference frame or the observer, you can say the reference frame is nothing but the observer also. Observer could be in motion or in rest. So this concept has to be understood properly, because there may be some relation which has to be established according to the reference frame which are in motion, and sometimes with the reference frame which is in fixed. Say for example, we are there on the earth. So we all know earth is moving, and we all are moving along the earth, but we don't feel that motion, because the earth and we are not relative to each other. We are moving together. So one other term which is coming is relative. Okay. This is because the concept of reference frame, because we need some observer to observe the motion, then only we can conclude with that reference frame or with respect to that observer, what he can see is the motion of the object. We cannot say universally in any reference frame, and with that every motion you can calculate. No, not possible. As because the thing that will clear you much. Earth is spinning. This has both spinning and rotary motion. But as a person on earth cannot even imagine neither of this motion. Why? Because we are seeing the motion of an object on the reference frame itself. Because if we are reference frame for Earth's motion, we cannot judge it whether it is moving or not, because we don't feel that motion. So as a person, as an observer, if he is in the same reference frame, then for him the object is standstill. So an object is in motion or in rest is only depends on the observer or the reference frame, isn't it? Till now I have described that if the reference frame is moving and the object which we are or the observer is seeing is out of the reference frame, then the motion can be studied. If the object is in same reference frame, we cannot see the motion. Let me take another example, because earth you cannot imagine and cannot prove it. Rather, with a practical example you can also understand. There is a bus which is moving at a certain speed onwards. Now two persons are sitting on two chairs side by side. There may be several more persons. Now if I consider this observer, the observer 1, and this is observer 2, what could he feel with for this? If you consider this is an object and his motion or her motion has to be studied by the observer 1, what could he see? All the bus is moving, all we are moving, all in the same. Now bus is your reference frame and this person is your object for studying. So as bus is your reference, because this person is sitting on the bus, he is included in the reference frame. What he could see? Can he see his motion? No. You can also have realized while you are moving in a train or a bus, the peer on your nearby seat, you cannot see because he is sitting as we are sitting. Even if not, the person is moving into the bus. That is a different phenomenon. I will come to that. But first, he is also sitting. If he observe this one, he won't get any motion of the object 2. So if it is same, so we can say the observer is in the same reference frame and the object is on the same reference frame, although the bus is moving with a velocity. Okay, so this way, if the reference frame and the object is in the same reference frame, we cannot study the motion. So what we are discussing also, let's say some person is moving along from the rear seat to the front seat to get down before the stops comes. So now what would this reference frame can see? He can see the person is moving with some speed. How we can see? Because the reference frame and the object in the same reference frame we cannot see. But what we see is the only physical movement from a place to another place. So when we can see, if any person on the reference frame starts moving, then only that motion can only be seen. But the motion caused by the bus running cannot seen by the observer differently for any person within this frame. So this person, if he starts moving, only I can see his walking along some platform, just as we all lying on the earth surface, and the person who stands still can see this person moving, but this is the only motion he can see if he is moving physically. He is changing its place one place to another. Not that due to the spinning of the earth, it is additionally added to this person motion, and that can be seen by the person who is on the frame itself. This only can be seen if you assume some other planet and he can see if the person is there, then only he could see that his motion, his speed, plus the or speed is added, and he can see the person is moving on the speed. So when you are changing the reference frame, then only he can address the motions which are all added together. Otherwise, if in the same reference frame he could see the relative motion. So here, if he in rest, both are in rest, there is no relative motion between that. There is no relative position changing between them. They are not changing their position. But if we see this person moving, that means relative to him, he is changing his place in the same reference frame. While even though the reference frame is moving, all are getting same motion due to this speed of bus. We can say speed of bus, but while seeing the same person on some other person on the bus which are in rest, you cannot see any motion because relative to him he is not changing his place, whereas this person is changing his place, and that can be observed by the observer 1. Okay, so this is the relative motion concept. Okay, so on that basis the reference frame also can be defined and derived. So now assume some person on the road, how he could see? If he sees these two person, they are moving with the speed of the bus at a point of time. They are not differently moving, they are all in same motion. Okay, they are moving with the speed as the bus moving. But if we differently see this person, he could be assumed to be in a more speed than the bus speed, more than the bus speed at point of time when he is moving. So for him, he is faster than these two, even though they are in the same object. Now he is studying this total object as a whole, and different tiny objects or the part of the object differently, then he can see the motion of this person differently than these two. Okay. So this is of reference frame. So reference frame we have studied could be in rest or in motion. These are the two kinds. Then the bigger part, that is the scalar and vector. Scalar, first we will come to that. So first, before coming to the scalar and vector, we need to know the quantity. So quantity is what? Quantity is which we can measure physically. This could only be the best definition for quantity, which we can measure. So what we can measure physically is a quantity. That means if I draw a line, now this line, is a connections of dots. Now about this line, what are the information we can give? Because we know the line width is very thin. There may be a possibility that I can draw a line of this thickness. I can draw this or further thin line. So if it is physically measurable, is always anything which is drawn or being touched can be physically measurable. So in this case, I can measure the width of this, I can measure the length of this. So these are the quantity that I can say about this line. So this is measurable. So this is a quantity. So quantity is basically the magnitude of measurement. So the quantity which is measurable, quantity is that which is measurable, and the measure is the magnitude of the measurement. So if we say this is length, so this has some certain standard unit, because if I say the prior days where there is no understanding of the units, so they assume as some standard length as 1 unit, and with respect to that they could measure. But in later stage, universally, when things has to be standardized and people are coming across each other for the sake of business, they have come to a conclusion that we need some standard so that it can be accepted worldwide anywhere, and then the business may run. On the requirement of that, they have come to the standard. So everything has which is measurable have standard. Length have standard, weight have standard, time has standard. Everything which is measurable are have standards. So with the standards, this is something multiplied by the standard unit. So this can be converted into the multiplication factor into the standard to describe the length of the line. So this is a quantity which is measurable, and the measure is the magnitude of the measurement, and the magnitude is the multiplication factor, which is a, you can say, the numeric value to the standard of that measurement. So if I measuring length, so length has a standard, and which is universally accepted, centimeter, meter, feet, and all that, whatever be the available in unit system, in that we can convert it into that magnitude. Here also with this same, because it is a linear dimension, all linear dimension can be measured with the respect of unit standard of length. Okay, so you can say, so the quantity is which can be measured, and measurement is the magnitude of that. So anything which is measurable. Now see, there is some quantity of rice, you can say, in a bucket. So how will you measure that? You cannot quantify by counting. Counting is not possible, because counting is not the standard measurement technique. Counting, we cannot measure anything, or we can, because counting needs to have some characteristic. For counting, every item has to be identical. Items are to be identical. So in any measurement system, counting is not considered to be a standard method of calculation of measurement, because this needs the item have to be very identical in all respect, weight wise, density wise, size wise, and the size could be of any finite term up to which you can measure. Okay, so it can be a very difficult task to consider or to understand. So counting may not be a standard thing that has to be taken as a measurement system. Rather, the thing that should be considered is length and weight and your time. These are the standard thing that can be taken, and these are the fundamental quantity. Fundamental quantity are those which are not dependent to each other or to any other measure or any other units or standards. These are individually are the standards of measurement. So these are fundamental units. Okay, so what I am saying, if there is a container containing so much rice, the only possibilities is that if I assume if I consider the weight of this, because weight has mass into the gravitational acceleration, which will give you a weight. Weight is nothing but the mass into, so mass of individual matter can be differ. As a whole, if I take a, because these are identical as an item, because the grain of rice call I call a rice only. If it is differs with the size or shape, it doesn't matter, I will call it a rice. So if a rice, if I take the weight of one particle multiplied by the number of particle, or the as a whole the quantity, I can say it as a, I can represent it as a weight. So that will be the mass of the total quantity available, and this G is the constant factor multiplied. So this is a standard measurement system. So this is also quantity, can be measurable. So anything, let's say there is a glass of milk in it. So for that particular milk, because milk also there will be a difference in density and volume due to that, and the mixture in the, so if I consider this as a milk, so I can quantify is as a, one thing is as milk has also a weight, I can consider weight also, I can consider into volume also. Okay, by that I can measure. So this is physical quantity. Whatever we is measurable are the quantity. So I think quantity is well understood. Now there are two variety of quantity. One is scalar. So as I was saying, that quantity must have a magnitude. So the scalar quantity which has having magnitude is a scalar quantity. The quantity which has only the magnitude is a scalar quantity. But in quantity, what I have described, there is nothing else is coming only than the magnitude. So there could be one possibility only, the magnitude represented by the quantity is called scalar. The scalar having the magnitude only. But one more term that is coming, the direction. So how come the direction will affect the quantity? Okay. So when the direction is affecting the quantity, there is a special class it comes that is called the vector. So this is the special one that needs to have consideration of direction, not only the magnitude. So the scalar which doesn't depends on direction, the quantity which is doesn't depends on the direction, only have magnitude, is called the scalar, and the vector which depends on the direction is called, the quantity which is direction depends on the direction along with the magnitude is called the vector. So, and vector is represented by an arrow mark on his head, and the length will be the magnitude of it. Magnitude is the length of the vector, and the arrow is the direction of the vector. This way that vector is represented. Now you see, when it is coming magnitude, if I remove this, this is nothing but a line segment, and this is scalar. But when I am adding this arrow sign specifically towards east, so this is turning to a vector. So the vector is nothing but scalar plus direction. You can say that, because scalar part is same as this represents only the magnitude, so scalar must be there in a vector plus direction. If I don't describe anything, any physical quantity with a direction, you can assume it as a scalar. Okay, now how does this direction affects the magnitude. uh, Let me come to this. The way it is differentiate the scalar, the direction. If I say the car is moving towards east, with a velocity, with a speed, let's say, I'm now considering speed as the term, as because from scalar I'm going to the vector, so I will slowly come to that speed 30 meter per second. So now it is moving in the east direction. At the same time, a car is moving on the west direction, the same speed 30 meter per second. Now a person is standing there on the reference frame. He stands still, he is in rest. So what he would say to the examiner, that what he is seeing, then on his basis the calculation will start. So he can say the car, one car is moving on his direction with 30 meter per second, another car moving in the 30 meter second on the west. So what the examiner will conclude, it is coming now, there are the things, now it is coming as a reference frame. So we have to build some reference frame. If it is moving in a straight line, then we can consider only the two axis. Now with this two axis system, as you know, the y is positive upwards, this is x is positive, right? This is negative, this is negative y, isn't it? As per the concept of reference frame, which are in plane and depends on two axis system, which is perpendicularly connecting each other, and the right way direction is the positive and upward direction is a positive for y axis and x axis. The opposite one is negative. So if we consider this reference frame and we have to study this motion, then this motion has to be treated as positive, isn't it? Now this value has to be plotted on negative side, so this has to be seen as a negative. So now see, the value changes, plus 30 cannot be minus 30. Now if I consider this is to be referred in reference system, for representation I must plot it like that, minus 30 here, plus 30 here, or you can say it is not on the x-axis, will come for any time. Let's say after 1 hour, this is t basically, this is t basically. So after 1 hour, this is moving with the 30 meters, that will move. If it is displacement, so it will move 30 meter there on y-axis. So this will move like that. So ultimately I will get in contact with this point from the original point. If I join these two points, the ultimate position after 1 hour is there from the 0 position, and for this, after 1 hour, it is minus 30, that has to be minus 30. This way I have to represent this minus 30 and I have to connect this way. So now this position is what, minus this would be a minus 1 and minus 30. This is 1 comma 30. Now see the direction. So I cannot say it as same sign, because after an hour, if I have to calculate the relative position between these two, because these are moving upwards, so this would be the distance. Otherwise, if I consider first, so this will be merged in one point and I cannot distinguish their position, the ultimate position, after some certain time. So if I consider this also plus, so after an hour this also to be in the same position, but it is actually moving apart. So to represent that with the reference frame, I have to consider some point which is is in this condition, in this position. Okay, I'm sorry, I made wrong. This used to be in this position. After an hour, because hour cannot be negative, so after an hour, this will be the negative side there. Sorry. So this could be 1 comma minus 30. Now, if this is not read properly, the distance, the ultimate distance between them has to be this distance only. Okay. So now you have might have understood the concept of taking negative sign. If I won't take it, if it is positive, so both point will merge together. So there is no displace or distance between these 2 points, even though they are moving apart. That cannot be possible. If two persons are moving apart, they will create some distance in between. They cannot be in the same point. If I plot it in the same manner, that will be margin same point, though that is wrong. So to understand the reference frame, this must be negative. As our the traditional acceptance that this way it is positive, so this has to be positive, this is negative. If our concept is like that, the negative side is this side is left hand side is positive, then other one has to be negative. But this is the universally accepted that x right hand side is positive, y upward is positive. So this way you can see that how the direction changes the magnitude. Okay, so now the right distance between these two when it is apart can be calculated. So this way you can say the vector has to be mentioned with direction only, otherwise you cannot represent it with the help of reference frame. So this is the initial concept of vector and scalar. I will come to this subject more with some example and some more characteristic of this in later classes. So today is up to this. I'm just stopping here and I'll move to the next class.